Hello, we've been looking at forces recently, and today we're going to try and look at how a Newton meter works. Inside a Newton meter is a spring, so we're going to try and investigate how a spring stretches. What I've set up here is a spring above a ruler, so we can measure the extension. The ruler, 0, is at the bottom of the spring. And when the spring stretches, we can see how much longer it gets. We're going to try and put forces on. So I have 100 grams here. Can you remember how to change grams to kilograms? Kilo means 1,000, so what we do is divide 100 grams by 1,000 and get 0.1 kilograms. And then we need to change it to weight, and that was an earlier lesson as well. Mass is the amount of stuff that makes up an object, but the weight is the force acting down because of gravity. So if we multiply this by the gravitational field on Earth, 10 newtons per kilogram, we can get the weight. So 0.1 kilograms is 1 newton. So at the moment, we have no newtons on our spring. And as you can see, the extension is 0. Let's see what happens when we put 1 newton on. When there is no force on the spring, the extension is 0. When 1 newton is placed on the spring, it extends like this. And if we look at the value, the extension is 4 centimetres. Placing 2 newtons on it extends it further, and if we look at the reading, it is now 8 centimetres. Third reading, 3 newtons, and if we look at our extension, it is at 12 centimetres. 4 newtons gives us an extension of 16.5 centimetres. The spring's getting quite long now. We've got 5 newtons on it, and if we look at the value, it is 20.5 centimetres. 6 newtons on the spring now. Let's see what the reading is. .5 centimetres. 7 newtons, and the masses are nearly down to the level of the bench. And if we look at the extension of the spring, it is 29 centimetres. 8 newtons. If we go in and look at the extension, we have an extension of 33 centimetres. I just want to stop for a minute here, because this point on the spring is quite important. At this point, if I take the masses off, the spring returns to its original length. This means that it's elastic. Elastic means that when the force extending it is removed, it will go back to its original length. Now let's carry on with the experiment. 9 newtons. Let's see the extension. So the extension is 38 centimetres. 10 newtons is 41 centimetres. 11 newtons, 48 centimetres. 12 newtons, 57 centimetres. I'm going to put the next one on while you're watching, because it might break. I think that was the point where it broke. So yes, the spring broke. And if you look, you can see that it has been permanently deformed. This means it hasn't gone back to its original length. This is called plastic. Plastic means that when the force is removed, the spring does not return to its original length.